Good day students. So in our last class we have seen about two-pass assembler. So under two-pass assembler, what are the functions performed in pass 1 and what are the functions performed in pass 2. So obviously our final output will be the object program. So the function of our assembler is generating an object program for the assembly language coding. So usually the object program will be generated dependable upon the location counter value. Initially we will start at a location counter value. So that initial starting of the location counter value is specified under the assembler directive start. So if the assembler directive start does not indicate any starting address, means in default we take 0 as the starting address, and depending upon the starting address we will set the location counter value for each and every instructions. Now consider a situation that our computer is a multi-programming environment. Multi-programming environment means different kinds of programs will be run at the same time, will be executed at the same time. Programs will execute concurrently to provide a multi-programming environment. In such scenario, the program will not be actually loaded in the address that we have specified. It will be loaded in some other location. So in such cases, what will happen to our location counter value and what will happen to the instructions that are dependable upon the location counter value? Because in final we have generated the object code depending upon the location counter value only. So the location counter value will get changed when the program is loaded at some other memory location, because we have assumed a memory location and we have returned the location counter value in such basis. For example, if my start assembler directive contains the value 2000, means I will write the location counter value starting from 2000, and for each instructions depending upon the format of the instructions that we have seen in our two-pass assembler, pass 1 and pass 2, how to increment the location counter value, and depending upon the location counter value how to form an object code. So we have seen that in two-pass assembler. So I will increment my location counter value depending upon the starting address that has been specified in the assembler directive start. So my location counter value will start from 2000. It may increment as 2000, 2006, 2009, likewise dependable upon the instruction. If consider my program is get loaded at address 5000. I have started the assembler directive with 2000, start with 2000 and generated the location counter value depending upon it. But now my instruction is starting at my program is loaded at the memory space 5000. So what change will be indicated? How this change will be reflected in my object codes? So that we are going to see in our program relocation topic. So program relocation topic discuss about how to change our object codes or how to load correctly the instructions in the memory. Program relocation. Program relocation is used in the environment when more than one program is sharing the memory at a time. So we don't know in advance which program will execute concurrently. So it is desirable to load the program into memory wherever there is a room for it. In such situation, actual starting address of the program is not known until the load time. See, consider for example, so this is a sample SIC program. My SIC program starts at location 1000. So in 1001B, I have an instruction LDA 3. Then at 1002D, the actual definition for 3 occurs. So how I will write an object code? LDA, the opcode for LDA is 00, and 3, the actual definition of 3 is at the location counter 102D. So by combining the opcode and the location counter value of 3, the operand value, we will form a object code. So 00102D is the object code for this particular instruction. Okay. See, consider if my starting address is changed to 2000. So the program will get changed. So my starting address is 2000. While loading 00102D, what will get loaded? Because when my starting address is changed to 2000, 102D, the target address 102D may contain some other program. So in 102D, we cannot find the definition for 3. So in such cases, there is a need to make some changes in the address portion in the instruction, so that it can be loaded and executed at address 2000. Okay. But some of the program remain the same regardless of wherever the program is loaded. Consider, for example, 0130 LDA #3. So this is an immediate addressing mode. So in the immediate addressing mode, the instruction itself will contains the object code, that is the target address. So here the target address is nothing but 3. So our object code is 00003. So wherever this instruction gets loaded, this is my target address, this is my value. So this kind of instructions need no change regardless of wherever this instruction is loaded. So likewise, a lot of instructions are there which do not require the change while loading. Assembler does not actually know where the program will be loaded. So it has to provide an identification for the loader, that is, which part of the object program need modification. The object program containing the information necessary to perform modification is relocatable program. That program is called as relocatable program. So it is the work of the assembler to provide an identification for the loader, that is, these are the instruction contents that need to be modified while loading, depending upon the starting address of the program. So relocatable program is nothing but when assembler generates an object code, it will insert the address relative to the starting address of the program. So depend upon the starting address of the program, it will insert the address. So assembler produce a command for the loader instructing it to add the beginning address of the program to the address field in the instruction at load time. So these are the instructions that need modification. For example, these are the instructions that need modification. So assembler, what it will do means, it generates an object code depending upon the starting address. So while loading, assembler instructs the loader that these instructions, for these instructions, the actual loading address has to be added so that it will be loaded at the correct location and the correct value for the operands will be fetched. So depending upon the starting address has to be added to this address field. So this instruction is provided by the assembler to the loader by means of a relocatable program. See, consider, for example, so this is the memory location. So let me take the instruction 150006 C loop plus JSET RD or EC. So the address is, the object code generated is 4B101036. This is an extended addressing format. See, consider this instruction. So this instruction, so the starting address of our instruction is 1000. Starting location counter value is 0000. So now 0000 is the starting address. So 4B101036, this object code is for this instruction plus JSUB RD REC. So the location counter value for this instruction is 0006. Then 1036 is the place where the operand RD REC is present. So this is the object code for this RD REC instruction. We do not worry about this instruction. So 1076 is the end of our program. Now we have written the object code for this instruction depending upon the value RD REC value. So RD REC is present at the location 1036. So I am adding here the 1036. Okay. So this is the memory location of my program if my program gets loaded at 0000. Now consider my program is loading at 5000. So assembler, it will instruct the loader that this is the instruction that need to be modified with respect to the starting address. So if my starting address gets changed to 5000, you have to add the starting address to this address field. Okay. So actual address of 4B101036 is 006. So 5000, now my starting address is 5000. So when 5000 is added to 0006, it becomes 5006. Then 1036 is the location of my RD REC value. So here also I have to add the starting address of my starting address of where my program is loaded in the memory. So 5000 is the starting address where my program is loaded into the memory. So this 5000 has to be added to 1036 also. So it becomes 6036. So when the starting address of the program during loading is added, my address gets changed correctly. See, so now 4B106036 will contain the actual RD REC value. So this instruction will get executed correctly. So depending upon the starting address has to be added to the instruction that require modification. So this information is provided by the assembler to the loader so that loader will add the starting address to the instruction that needed modification. So that information, that command given by the assembler to the loader is inserted as a part of the object program by means of another record called as modification record. So modification record will contain the details about for which instructions we need to add the starting address during loading. So now let us see the syntax for writing the modification record. So column 1 will contain M, column 2 to 7 will contain the starting location of the address field to be modified relative to the beginning of the program, starting location. Then column 8 to 9 will contain the length of the address field to be modified in half bytes length. So length has to specified in half bytes. Okay. Now let us consider the same example and how we have written our modification record. So plus JSUB. So plus means it is an extended format. So extended format, for extended format the address field is 20 bits. So 20 bits can be written as 5 half bytes. So 1 half byte is equal to 4 bits. So therefore 20 bits is equal to 5 half bytes. So modification record, the modified record for this instruction is M. Column 1 contains M and 2 to 7 will contain the starting location of the address field to be modified. So the starting location of this address field is actually the appropriate location counter value is 0006, but the starting address will be next to this location counter value, that is 0006 plus 1. equal to 0007. Okay. So usually the starting address has to be added with the location counter value. If the location counter value is 1006 means the starting address of the address to be modified for that to the instruction for which the modification record has to be written is location counter value plus 1. Keep that in mind. So the location counter value plus 1 will give the starting address of this instruction. So our location counter value is 0006. 0006 plus 1 becomes 00007. So we have to write in 6 digits. Then column 8 to 9 will contain the length of the address field to be modified in half bytes. So what is the length of this address field? So this is an extended format. So length is 20 bits. If we represent in half bytes, it is 5 half bytes. So 05. So this is the starting modification record. So this modification record specifies that the starting address of the program is to be added to a field that begins at 00007 and 05 specifies the address in half bytes. Thus, in above object code for plus J sub instruction 4B101036, the first 12 bits 4B1 remain unchanged wherever the program is loaded. Then the program load address will be added to the last 20 bits. Last 20 bits is 01036 to produce the correct operand address. So now let us see the respective object program and how this modification record is inserted in our object program. So this is our object program. So this is the header record of the program and this is the text record. At the end of the text record and at before end record, we will write the object modification record. So the same modification record I have written for this object code. See 0007, I have already told how to form this 0007. That is, you have to add 1 to the respective location counter value. The respective location counter value is 0006. So 0006 plus 1 becomes a starting address. 0007 becomes the starting address of this object code. See, in this object program, how to find out this 0007. See, this is one object code, this is one object code. So each is of 3 bytes. See, this is 1 byte, this is 2 byte, this is 3 byte, third byte, and this is 4th byte, 5th byte, 6th byte. Okay, and this is 7th byte, 8th byte, 9th byte, 10th byte. So actually this is our object code which needs to be modified during loading. So what is the starting address of this object code? 7. So this is the starting address of the object code in the object program. So 7 is the starting address. So I have written 0007. See, consider, for example, if there is another address like this 1817668. So this is another object code. Now how to write the modification record for this object code depending upon the object program? So this becomes 11, 12, 13 and this becomes 14, 15, 16. So 14. How to write 14 in hexadecimal? It is E. So M, the starting address is 00000E. Then how many bytes is this instruction? So this instruction is a normal format 3 instruction. So for format 3 instruction, address is equal to 12 bits. 12 bits means how many bytes? 4 half bytes. Four half bytes. 12 bits is equal to 200 bytes. So 200 bytes is 4 half bytes. Sorry, 3 half bytes. Okay, 3 4s are 12. So 3 half bytes. So you have to mention the address field in half bytes 0, 3. Okay. So this is the modification record. Hope you understand how to form the starting address of the object code to be modified. In simple, you just check the location counter value. So just add 1 to the location counter value and that becomes the starting address. If an object program is given, you have to add like this. Okay, this is for a specific text record. So the object code has to be added in an incremented way. So if this text record gets completed here and if a text record starts from here, you have to start the location from 17. So this is ended with location 16 and this object program will starts with 17. So you have to add the address field in an incremented manner. So by means of an object program, this is the way for calculating the starting address. If a program is given, just see the location counter value and add 1 to the location counter value. That becomes the starting address for the instruction that need to be modified during loading. So this is how an assembler provides a command to the loader during program is relocated in an address that is apart from the address that we have specified and written the location counter value. So this command is provided by means of a modification record. So this is the information in program relocation. Thank you.